This lesson is on radicals, and we're going to take a minute to do a quick overview of how we're going to simplify and work with radicals. So, we are always going to look for perfect squares or perfect cubes, depending if we are taking a square root of something or if we are taking a cube root of something. We're going to factor and group as perfect squares or cubes as we need to. We're going to leave the rest as a remainder under the radical. This is how we are going to start working with exact answers, no more decimals. And coefficients that come out front are multiplied. So when we think about perfect squares, like 16, if you think about the square root of 16, we can really think about that as the square root of 4 squared, and square rooting and squaring are opposite operations, and so the answer is 4. So when we talk about factoring and grouping as perfect squares, this activity here is what we're going to do. In the same way, if you have a perfect cube, for example 8, which is really 2 cubed, I can take the cube root of 8, which is the cube root of 2 cubed, and cube rooting and cubing cancel, and I'm left with 2. So we're going to go back to the old days of factor trees. So I am taking the square root, so I'm going to factor this as 9 times 3. Remember, I'm looking for perfect squares, so this is x squared times x. So if I think about rewriting that, and here's the key. There is a rule that says if you have the square root of a product multiplying, you can take the square roots separately of each part. And that's what allows us to do that. So I can rethink this as the square root of 9 times the square root of 3 times the square root of x squared times the square root of x. I haven't done any math, I haven't changed my number, I just factored. So now the square root of 9 is 3. The square root of 3 is left over, so I leave that under the radical. The square root of x squared is x, and the square root of x I can't do anything with. So my final answer is 3x square root 3x. If I go on to this next example, I already have a 5 up front. That's like a coefficient. And so I need to think about that in terms of multiplying out front. So I'm going to go ahead and factor 448. Now I can do it by perfect squares, or I can do it all the way down to prime numbers. I know 4 goes into that. It goes in there 1, 1, 2. I'm going to leave that because that's a perfect square. I don't know what goes into 112, except I know 2 does, 56 times. Well, I know that's 7 times 8. And I know that is 4 times 2. And when I get to a perfect square, I'm going to stop. R to the 4th can be rewritten as r squared times r squared. Now remember what I'm doing. I'm trying to write these as perfect squares. So to rewrite this so I don't lose anything, I have negative 5 out front, square root of 4 times, I have 2 2's, 2 squared, times 4 times 7 times r squared times r squared. So you want to be very precise in your factoring and your rewriting so you don't accidentally leave a term out. Now I can go ahead and say negative 5, draw my radical for my leftovers. The square root of 4 is 2. And remember, when it comes out front, it's multiplied. 2 squared is 2. The square root of 4 is 2. I can't take the square root of 7, so that goes under the radical. Square root of r squared is r. The square root of r squared is r. Clean it up. Negative 5 times 2 times 2 times 2 is negative 40 r squared square root 7. And that is in lowest terms. Now we're going to switch to a cube root. So now we're looking for cubes. We're looking for factors that show up 3 times. So if I go ahead and start factoring this, 2 goes in here 128, and 2 goes in here 64, and 2 goes into 64 32, and 2 goes in there 16, 2 and 8, 2 and 4, 2 and 2. Now I took this one all the way down because I'm looking for cubes. Now 8 to the 6th, I'm going to rewrite that as a group of 3 and a group of 3. I still have 6 there. I just rewrote it in those groups of 3. And b squared, I can't make a group of 3 out of that. So if I think about rewriting this one, I have 5. And remember doing cube root. So I'm going to go 1, 2, 3, 2 cubed. 1, 2, 3, 2 cubed. 2 of them, 2 squared. That is still 256. I just rewrote it as cubes. Then I have a cubed, and b squared. Now I'm thinking about what are the perfect cubes here. So the 5 stays out front. Here's my leftovers. So what's the cube root of 2 cubed? It's 2. The cube root of 2 cubed is 2. The cube root of 2 squared I can't do, so 2 squared stays under. The cube root of a cubed is a. The cube root of a cubed is a. The cube root of b squared I can't do, and so I leave it under. So I clean it up. I have 20a squared, and my remainder is 4 cube root of 4b squared. So we're thinking about opposite operations to undo different roots. So if we think about doing a 4th root, we're thinking about what factors show up 4 times in this problem. So let's go ahead and factor 162. So I know 2 goes in there 81 times. I know that's 9 times 9. That's 3 times 3. And that's 3 times 3. And I circle the ends of my prime factors to help me keep track of them. Now out of x to the 5th, I could make a group of x to the 4th and an x. I still have 5 total, and y to the 4th or 8th I could do as y to the 4th, y to the 4th. So if I rewrite it, I have 4 times the 4th root of 2 times 3 to the 4th. So I did that one, 4 of them. X to the 4th times x, y to the 4th, y to the 4th. Again, all I've done is factored. I haven't changed the value of my problem. So now I have 4 and my leftovers. Can I take the 4th root of 2? Nope, so that stays under the radical. The 4th root of 3 to the 4th is 3. The 4th root of x to the 4th is x. I can't take the 4th root of x. The 4th root of y to the 4th is y, and the 4th root of y to the 4th is y. So if I clean it up, I have 12xy squared times the 4th root of 2x. And that's how you simplify radicals exactly. Now if we think about doing operations, we're going to go through a longer section of the video, so go ahead and tune into part 2.